Okay, so we're just about on time to get started with today's session. So welcome to everyone who is joining us. You're here at the Natural Language Processing series. So this series has been running over the last few weeks, and I'll show you on screen shortly where we are in this series. To those of you who are new, you're very welcome, and we look forward to having you here on this session. Today we're looking at the fundamentals of text mining. So this session will run over the next 60 minutes, and that's including any questions and answers. So there is a Q&A window for you to ask any questions that you have throughout. Any conversation as well is welcome within that Q&A too. So do feel free to use that window as we go through today's session. We are recording all sessions within this series and they're available to watch on demand. I'll share the link within the Q&A window shortly. So before we get started today, this is just a very quick reminder to everyone who's with us of our code of conduct. So we display this at all Microsoft Reactor events, and it's just a reminder to everyone to be aware of one another today, understanding of any differences of opinions that we might see throughout the Q&A or in any conversations, and just to really maintain a friendly and inclusive environment throughout today's session. Our speaker today is Fatos Ismali, who is a cloud solution architect at Microsoft. We're delighted to be welcoming Fatos back today to deliver another session within this series, and we'll hear from him just shortly. So again, this is just a quick reminder of what we have already covered in this series. So you can see on the screen the sessions that have already been delivered. As mentioned, they're all available to watch on demand, and I will share the link with you in the Q&A soon. And today we are looking at the fundamentals of text mining with Fatos. So without further ado, Fatos, I'll hand over to you to kick us off.
Great, thank you, Emma. Perfect. Okay, so let me just share my screen first. Okay. Let me know when you can see it.
Yeah, we can see that.
Cool. Perfect. Yeah. So hi, everyone. Afternoon. My name is Fatos Ismali. I'm a cloud solution architect here at Microsoft UK, and I specialize in data and AI services within Azure and open source as well. So for today's talk, I'm going to be covering text mining or knowledge mining. We'll be covering a few techniques on, how we approach text mining from a Microsoft perspective, how we productionize knowledge mining or text mining pipelines, and I'll talk about Azure Search most predominantly during this presentation. I will also cover something called aspect mining or opinion mining, which is a different type of more granular type of sentiment analysis that can be applied on textual data and has some really interesting use cases out there in the industry. I'm also the founder of the Data Science Initiative community, which you may have seen, some of you who have registered for this event. So stay tuned on that for upcoming events as well. Great. So on that note, I'll kick off that with the presentation. Actually, what I'll do is I'll try to stop my camera just to save some Wi-Fi speed here. Okay, that's perfect. All right. Okay, so when it comes to text mining in general, you're talking predominantly about unstructured data sets. So data sets that come in textual format, text information or textual information that is embedded in images. It could be video files. It could be PDF documents, Word documents. It could be even scanned documents, right? So these physical books that you see here in notes, they could be digitized, right? You could take a picture of them, you could digitize them, and then you can extract the information out of those pictures, so the textual information, and then you can gain some insights from that textual data. And this is what we kind of when we encapsulate this, understanding the latent value in all the content, not just structured data that we're used to typically in the industry, right? Like tables and dealing with languages like SQL. You can actually leverage technologies today to untap the value and the insight from all the types of unstructured data sets. And at the center of it, of course, is AI techniques that we leverage to, for example, take a picture of a whiteboard with some text in it. We can actually extract that piece of text and transform it in something that the computer can represent digitally. So in this case, we take that piece of text written in handwritten format, and we extract it and actually present it in a, machine readable format, like in this example. We can also pick up images and we can describe objects in those images. We can potentially take tags, and then out of those tags, we can form meaningful sentences or captions like you see here. And we use AI techniques to do all of this. And I'll show you a few demos of where we as Microsoft are innovating in this space and leading in this space with our technologies. And of course, loads of companies out there, insurance companies, financial services companies, have loads of forms that contain unstructured information, unstructured text, or they just want to extract the valuable pieces of content from those forms or text or documents and present them in a digital format so that the computer can understand, or at least derive that structure that you need out of those unstructured file formats. And usually the way we approach solving this problem today is using our cognitive services. And as you can see here, we have quite a list of cognitive services, and there's a reason why we call them cognitive, because they tackle some of the human faculties like vision, speech, language, knowledge, and search. And that's what we're going to talk about today most of the time. But all of these services that you see here tackle the specific problem of the human mind faculties in a way, right? So vision, speech, language, or knowledge, and search will be our focus today. Of course, you can tackle this using open source technologies, and we are big lovers of open source, right? So we embrace open source in everything that we do today within Azure. And you will see me walking you through an example later today where I show you how you can embed, for example, Python code that can leverage any of these open source libraries that you see here: Spacey, NLP Architect, NLTK, Stanford NLP, etc. And you leverage the functionality or the code that you're used to doing within NLP in terms of insight extraction from textual data, entity recognition, sentiment analysis, etc. All of those can be embedded within this search pipeline that I will walk you through today. So Azure Search is our technology when it comes to, let's say, indexing unstructured data sets and structured data sets, right? So it could be CSV files, it could be TXT files, it could be JSON files, it could be images, video calls, etc. We can index all that data using Azure Search, and then we can provide capabilities on top of that data so that you can actually search that using natural language. You can, of course, use operators to do smart searches on that data. You can do stuff like AND operators, OR operators, and more complicated, complex operators within Azure Search. And then you can also provide what we call skills on top of Azure Search. And that basically allows you to enhance your indexed data with more insightful information, such as extracting entities from that text, or extracting stuff like people, locations, organizations. You can extract all of that information automatically using the Azure Search technology that comes within this offering. And we support multi-language support, right? So you can index not just English documents, but you can index other languages like Spanish, German documents, and you can provide all the skills that you see that you're going to see today on top of that data. And typically the very high level picture of how that looks like using Azure Search is you have this ingest process where you basically take the data that you have, unstructured data, structured data, land it into an Azure storage account, and then you index it using our search utility. And then on top of, once you index the data, and typically when you index, you use some sort of indexing mechanism like TF-IDF, which is the term frequency, document term frequency, to inverse the data into a document frequency and inverse document frequency matrix, and then you can easily search on top of that using Azure Search. And Azure Search implements that behind the scenes as well. And then on top of that data, index data, you can then apply all these different cognitive skills, as I mentioned, like entity recognition, sentiment analysis, PII data reduction, right? So I'll show you all of that. And then once you enhance, or once you enrich the index data with all these different skills that we call them, you can then explore that using a UI that you build, or a UI that you can build today out of the box with a click of a button. I'll show you how to do that using one of our solution accelerators in this space. This is how the cognitive search, and you will hear our search service being also interchangeably referred to as cognitive search. They're basically the same technology, but the architecture stands like this. So you have your customer data or your data, which could be PDF, documents, JPEGs, etc. You use our search functionality to index that data. You apply cognitive skills like key phrase extraction, extracting entities, sentiment analysis, etc. And then you can also embed third-party cognitive skills. And this is what we mean by third-party enrichers. So maybe, key phrase extraction, people names are not enough for your use case. You can actually embed your own custom Python code into this pipeline, and that Python code could potentially leverage some of those open source libraries that I showed you earlier, like NLP, NLTK, NLP Architect, Stanford NLP, etc., or Spacey, and you can enhance. You can bring in new functionality in as part of these cognitive skills, and you apply that against the index data that comes out of the Azure Search indexing process. And once you have that cognitive skills, let's say, applied, you have then your annotated documents, which is your enriched documents with all these different skills that have been applied against them. And then you can, of course, do the searching on top of that. This is how you would embed, let's say, a custom skill if you wanted to create one. And I'll show you a concrete example later in the session of how we leverage Azure Functions to build basically a Python-based Azure Functions that leverages our text analytics service. So text analytics is another service that we're going to cover today that primarily deals with sentiment analysis, opinion mining, aspect mining, which is that other topic that we're going to discuss today. And the way we integrate the two, so Azure Search with text analytics, is we create a Python code that interacts with text analytics API as part of an Azure Functions. And you can then just trigger the Azure Functions using an HTTP request from the Azure Search functionality. And I'll show you how to do that to extract, let's say, for example, the aspects or the opinions from a piece of text. Okay, so at this point, what I'll do is I'll cover a few demos and walk you through some of the solution accelerators that we have in the space. So, and I'll share these links with you as well. So this one, to start with, this knowledge mining solution accelerator. I think this is a great starter for you guys if you want to get your hands dirty with Azure Search. And this solution accelerator has been built from the ground up to give you an easy way to deploy this interface that you see here with some predefined data sets that we provide as part of this accelerator. And once you deploy the solution, you will have a web app that looks like this in the photo here, with all the different key phrases that you have at your disposal, like filtering by key phrases, filtering by locations, organizations, persons. All of these entities have been extracted using those cognitive skills that I talked about, and all this data has been indexed by Azure Search and is provided to you using a user interface, friendly user interface that you can interact with. And all of this is obviously part of this process that you take. So you first deploy the resources, such as Azure Search. If I were to click on this button, deploy to Azure, I would be taken to this new screen, which takes me through. If you have an Azure subscription, of course, you have to have one. You can, of course, sign up for the trial, a $150 trial Azure subscription, just to test this out without paying anything. So you can use that to basically deploy this solution. And once you fill this and you hit review and create, that will basically create the entire resource group, which is this encapsulated kind of encapsulation of services. So they basically are embedded into a resource group. This resource group will contain all these different services that you see here. So you will have the search service, which is this bit, which is what we're covering today, the search service, the function, the tool that actually does the indexing and applies all the cognitive skills. You will have app service website, which basically is that front-end user interface. You will have cognitive services, which you can use for things like OCR and image extraction, text from images, etc. An app analytics, application insights instance as well for monitoring what your search service is doing, a functions app, etc. Right, so you have all these services that get deployed once you hit review and create as part of that deployment process. And then you can go through the next step, which is creating that web UI template. The website that you see here has been built in C#. So when you click on this web UI template, you will be able to then open a solution in Visual Studio in your PC, and you can actually deploy that web app straight into your app service that was deployed from the first step here. And then you go through a process of creating the search-specific functionality, like creating the index, so indexing all your data, which is the PDF documents or text documents or whatever unstructured documents you have. And it could be a mixture of those, right? It doesn't have to be all the same documents. It could be a mixture of, PDF documents, TXTs, Word documents, images, etc. So you go through that process of creation, and the way we do this is you can either leverage the Search SDK or the REST API. And as part of the solution Accelerator, we provide a Postman collection. So if you haven't used Postman before, Postman is a application, a desktop application that can be installed on Windows, Mac OS, Linux, and you use that to basically issue REST API requests against web services. You can issue a put request, get request, post request, etc. So here, when you download that, when you git clone this repo here, this Knowledge Mining Accelerator repo, you're given this cognitive search pipeline APIs collection in Postman, which comes with all these different steps that you execute in a sequence like this. So you first create the data source. So all you have to do first is, of course, you have to define the environment variables here, which I already defined. So I'm going to show that here. And once you do that, then you just go through these steps. So creating the data source first. So what that does is it goes here. So if I click on the search service, it will actually create my data source, which points to a storage account where all my emails are. In this case, I'm using an email data set. And then I go and create an index. So this is basically now saying, okay, go and create an index that's going to point to that storage account. And then I'm going to say, okay, create a skill set. And here I'm sending a post request, or a put request rather, which contains all my different types of skill sets. So what am I expecting to do on this data set once it is indexed? So I'm going to leverage the OCR skill sets, and this is how you define them. So this is going to be used to extract key phrases and entities from potentially images or like scanned documents. What else do I have here? I have the split skill set, which basically takes a piece of text and splits it into sentences, for instance. Key phrase extraction skill set, which basically takes key phrases from the text. Entity recognition skill set. You can see these are inbuilt skill sets available today in Azure Search, and there's a whole list of these. So if I go to skill sets here and I click on email and index skill set, which I just created using that Postman request here, create skill set. And then if I show you the interface, so basically you see everything that I showed you in Postman, you see here as well as part of search. And in here, skills, you can see all the types of skills that you can actually leverage that are inbuilt that come with Azure Search. So you can have all these ones. You can have PII detection skill. You have a translation skill if you want to translate from foreign language into English or vice versa. You have shaper skills, OCR skills for vision type applications. And you can create, of course, a custom web app skill. And then you can define that here. And this is, for instance, how we're calling a custom skill, a web API skill. So this web API skill within Azure Search allows us to make a HTTP request from Azure Search against a URI, which could be anything. It could be a functions app. It could be a Lambdas app in AWS. It could be anything that accepts a REST API request. And the returns, in this case, the function will take a piece of text, and it will return basically some sort of opinions and sentiment out of that. So that's what happens with this web API skill. And I'll walk you through that later. But a good example of this solution accelerator, which kind of leverages the same concept, is provided here in the Art Explorer. So this is, and I'll share this link with you. This is from the Metropolitan Museum of Art, which is actually using our cognitive search technology to index everything that they have, all the assets in terms of like all the artistic assets that they have, paintings, etc. And you can see here, it's very similar to that solution accelerator interface that you saw. You have tags here, filtering by tags, filtering by periods, medium, department, artist, etc. So I can search for French paintings, and immediately I can see all paintings that are related to French. Now you may think, actually, how do we, if we have images but we haven't tagged them, or we haven't provided any captions, how could I potentially provide that if I don't have that information, right? So because Azure Search will want to see a lot of text. The text could be embedded in the image itself. It could be part of the image metadata. It could be a tag that you basically associate with that image. But as long as the text exists, but if the text does not exist, where can you get that text, right? To enhance your let's say your images with more descriptive textual data. So for that, we have another service that is just being built recently called Azure Florence. And this uses a new piece of technology that combines, it's called meta learning, basically. Not meta learning, it's actually called multimodal learning. That was my mistake. And it combines vision and language together to create a more enhanced deep learning model that leverages both of those to generate captions from, let's say, tags or just images. So for example, they have a demo here, and I'll share this caption bot demo, which leverages that vision and language algorithm behind the scenes. So I picked up one of those images from the Metropolitan Art Museum, which is this man here. And I just wanted to say, okay, let's see what the algorithm says. And you can see, I think it's a man in a black robe. That's what the algorithm basically comes out of without any textual information about this image. So you kind of understand that this is a man in a black robe. Similarly, I took another image from that art museum, and it's saying this is a painting of a group of plants, which is pretty accurate. And also about this woman, it's a woman holding a book, right? So you could potentially leverage other AI cognitive services that we have as part of Microsoft to enhance your existing data, your pictures in this case, so that your Azure Search functionality can actually index all that text that you generate out of that image captioning process. So that was just to show you the art of the possible in terms of how you can combine multiple technologies to enhance this search capability. Another example is, and I'll share this as well, is the JFK files, right? So this is the John F. Kennedy files, which are, obviously all available in the Assassination Records website here, the archives.gov website. And this is basically all PDF documents. You can see, for example, an example of this PDF documents here. You can see everything here is scanned. Like you cannot actually select the text here. So assume that you had a use case where you wanted to analyze all this data. If you were to do this manually using, let's say, Python, it would be quite a pain because I've tried to do it myself. You have to use OCR libraries, you have to extract the text, you have to take care of pages, you have to go through, lots of hoops until you get it right. With Azure Search, you can actually do this quite simply and quite fast. You just put all these documents in like a storage account, like I've done here. So all these PDF documents. And then I'm just going to say, okay, Azure Search, index all that storage account with all those PDF documents. And once I index that and I create that, interface that you saw here, for example, this is what I can do with that data, right? So this is a new type of interface, which is basically leveraging Azure Search. Again, it's the same type of interface like you saw earlier. It's just more fancy with backgrounds and colors, but you can see I can filter by tags, I can filter by redactions, I can search for Oswald, and when I click on Oswald search, I can see Oswald appearing in all the different scanned documents here. And it could be handwritten or just a scanned piece of paper with text, right? So it could be all kinds of documents that I can see here, and even the picture of Oswald, or yeah. And then yeah, Lee Oswald, you see it's highlighted as well, where in the document actually is finding that word. I can search for Kennedy. So if I search for that, maybe I can see all pictures of Kennedy as well. You can see here, they're popping up from forms and documents that I have indexed using Azure Search. So it becomes quite powerful. I can also, see all the different types of names and, organizations that I've extracted automatically using all the cognitive skills that I spoke about earlier. And that allows me to then just filter by those using these tags here that you see. Right. So again, this solution can be deployed as well using this repo in here, and you can see also the architecture of the solution here, which is depicted here, and it's pretty similar to what I showed you in the high-level architecture of Azure Search. You have your data stored in a storage blob account. Azure Search will take that, it will index that data, it will extract all the information from that. It will apply all the skill sets, the OCR, the handwriting, text extraction, computer vision algorithms on top of that, sentiment analysis, key phrase extraction, entity recognition, all of that. And it will make that searchable through a natural language interface that you just saw. Okay. Another solution, Accelerator, that we have out there, this actually combines the power of Azure Search with the power of Azure Machine Learning Service. So if you want to do something more fancy, for example, you want to maybe embed some sort of BERT model, and you want to train that BERT model on textual data that you receive. So you get some label data. So this is a classification example, and you want to you first wanted to search, like index all that data, generate the label data, index it, and then kick off a training process that trains a BERT model on top of that data, and then make that available back into cognitive search. There's this solution Accelerator that allows you to do that and shows you step-by-step examples of how to achieve that. And again, this is useful for taking that extra step in actually going more in an advanced area. So you're actually introducing machine learning and embedding that into this process as well. Okay. Okay, so yeah, so that was one example. So then, so if we go, like, I guess, more details into each of those areas. So document cracking, we support all types, right? So we support different types of data storage support, like blob storage accounts. So you can index a blob storage account, which can contain all types of unstructured data sets, like we discussed. You can actually index data from Azure SQL database, or as I mentioned, this technology, Azure Search, is not just for indexing unstructured data set. You can actually index structured data sets as well, like tables, and could be SQL tables or NoSQL tables, like Cosmos DB here. Azure tables are a type of relational data structure that gets stored in blob storage accounts, MySQL as well. And then different types of file formats, PDFs, docs, PPTs, HTMLs, like a range of file formats out there. And in terms of skill sets, as I mentioned, you have quite a range of inbuilt skill sets functionality that come with Azure Search. And of course, you can enhance that with your own, bring your own skill set, if you will, if you want to use that term. So you can then just bring your own using your favorite language. It doesn't have to be Python, by the way. It could be Java, it could be JavaScript, right? So anything that can be embedded within an Azure Functions or any other web service that you find out there. It could be, for example, a Flask application that you have created and you are hosting that in a different server, and you want to interact with that Flask application from Azure Search. You can do that, right? It's just a REST API call. So as I mentioned, the web API skill is what you would typically use to enhance the embedded or the inbuilt skills that come with Azure Search. And this is just kind of going through the more details of how you would define that within Azure Search, what type of input that custom skill would be required, would expect to have, and what is the output that it would, I guess, generate. And I'll show you an example of how we interact with text analytics when we get there. And of course, as I mentioned, if you're using, for example, Azure Functions to develop your custom skills, you can use Python, Java, JavaScript, C#, PowerShell, all these languages within Azure Functions to develop your code and surface that as a web service so that Azure Search can call it. And skill sets, just a basic example here, extracting key phrases, organizations, classifying documents, like with that BERT that you saw earlier. You can also create chains, so enrichments on top of enrichments. For example, you can have a pipeline that says first detect the language, and if it's English, extract key phrases. If it's another language, extract organizations. So you can actually create these chain lists, or we usually call it, technical term is DAGs, directly acyclic graphs, that you can create using these skill sets that you see here. And here's an example of how you would do that. So you have a language detection skill that you define first, that basically first defines a scale, applies a scale of language detection on your content, your document/contents, which is your text data. And then you basically say, okay, the output of this is going to be my language code. And then that serves as the input to your next skill, which is in this case a named entity recognition skill. And you can see here the source for this is the language code. So first I'm going to say, give me the content of the text and also the language code that I just got from the previous step, and use that as my input into this named entity recognition. Then I can say, okay, if it's this language, do something like this. If it's another language, do something else. So you can do that. Then you can apply skills against multiple elements or multiple, let's say, entities. For example, if you have loads of organizations, you can apply skills in an array of organizations, right? So let's assume that you have loads of organizations in your text and you want to apply some sort of custom skill or inbuilt skill against each of them. You can do that using the syntax here. And then once you apply your all your skills, you basically annotate the document with all these different types of enriched information, which could be all the extracted key phrases, the organizations that you extracted, the images, the language codes, etc., etc. And then all of that is basically available for you to search using natural language, and you can then create that user interface using C#, JavaScript, right? So it depends on which language you might use. Right. Okay. So you saw this was the JFK architecture, which was, and then the other bit was of this presentation was to focus on text analytics, right? So now that, let's say you have indexed all your unstructured data set using Azure Search, you have applied all the cognitive skills, you have you even extracted some sentiment analysis from the text. However, the sentiment analysis feature, the inbuilt feature that comes with Azure Search, only gives you stuff like 3 classes, right? It gives you only positive, neutral, and negative. Let's say you wanted to go even deeper than that. For example, you wanted to understand the opinion or the sentiment of an entity, right? So let's say you have a piece of text, and I'll show you an example soon, but you have some text with some entities within that text, and each entity has some sort of emotional connotation attached to it as part of that sentence, and you want to understand how those two relate. So you can use our text analytics service to do that, which now has in version 3.x has this opinion mining functionality. And what is text analytics? It's basically another service, just like Azure Search. It's part of our cognitive services umbrella term that you use to define all these different types of cognitive skills, cognitive services that we have. Azure Search being one of them, Azure Text Analytics being one of them. And Azure Text Analytics specifically deals primarily with key phrase extraction, language detection, entity recognition, and sentiment analysis, with the new option now that we have called opinion mining. And opinion mining, as you can see here, is, let's say, for example, you want to see what the opinions for the word hotel is. So you can see, for example, the word hotel here, which denotes a name, right, a noun, and then you can see all the different types of aspects or opinions related to that hotel. So like clean, great, nice, excellent. So you can do this really rich analysis on your entities that are being mentioned within your text and see what is being said about those entities, right? So this is great for scenarios where you're doing, for example, product reviews, or for example, in scenarios like retail. So I'm working with a retailer today who is really interested in this technology, in this functionality. And then, of course, with text analytics, you can do named entity recognition, and you can extract some really rich information from your piece of text, like you see here, like person names, person types, locations, organizations, date, time, etc. All of this can be extracted with V3 now, and it's much richer than it used to be. You can also leverage something that came up again with V3 of text analytics that allows you to now take a piece of text that contains sensitive information and actually redact that information. For example, SSN numbers, social security numbers, names, email addresses, phone numbers. You can see here an example output. Once you apply the PII redaction functionality of text analytics on top of that piece of text, you can see how we have redacted all that sensitive information. So it's quite useful in industries like financial services, insurance companies. They're really interested in this type of functionality. So common scenarios of text analytics. So analyzing recorded inbound customer calls, and you saw an example of how you can actually take speech data and transform that into textual data using our speech-to-text service, which Kayo, one of my colleagues, for some of you that attended his call last week, I must have seen. So once you have that text data from the calls, you can then apply all these different types of enrichments that we discussed today. You can use search to index that data. You can use text analytics to extract key phrases, to extract opinions, to redact that information if it contains sensitive data. You can basically go through this whole end-to-end life cycle. Another one is monitoring your product's social media feeds. So maybe you're a retailer that sells a series of products and you want to understand what your users or what your audience is saying about those products. And this text analytics opinion mining feature is perfect for that, because it actually ties in each of the product's names or product types that you have, and then it actually sees what is being said about those products and what is the sentiment of what is being said. Is that aspect coming with a negative connotation or a positive connotation? And you'll see an example of that. Also, another one is classifying and redacting documents that have sensitive information, right? As you saw that example, there are some customers nowadays that just want this functionality, right? They just want to get all their unstructured documents, structured documents, and they just want to find sensitive information in those documents and just generate a redacted version of those documents that does not contain PII information, right? So think of GDPR type use cases where there's loads of compliance regulations that require this type of functionality. Text analytics will be ideal for this scenario. Okay, so let's show you now text analytics demo. And again, I'm going to use Postman, right? Because I'm assuming that you create a text analytics service in Azure, which is really simple to do from the marketplace. Once you create it, you can then just call the text analytics service using the SDK, or you can actually use the REST API. And what I've done here is I've created an Azure Functions that calls the REST API of Azure Text Analytics. And from what I do from Postman here, I call that Azure Functions instead of calling directly Text Analytics. So let me show you the Azure Functions quickly. So this is my Azure Functions. I call it the opinion mining function. And in here, I've, of course, imported all the different types of libraries that I need for text analytics. And usually when you create an Azure function, it's super simple, really. I'll share this code with you and I'll show you how to actually build this yourself. But you literally have a main method here, which executes all your logic, and your logic can contain anything, right? You can have, you can specify all your libraries in the requirements file here. So if you want to do, for example, leverage Spacey or NLP Architect or Stanford NLP, you can define them all in here, and you can make that part of this function. So you can build all the most complex, Python code within this function and have that executed as part of an HTTP request. So what I'm doing here is I'm expecting a JSON response or a JSON request, and the way I send that, let me show you here. Yeah, this is the one. So here I'm calling this opinion trigger, which is basically that function that contains all that Python code that I just showed you. And I'm sending body with this JSON structure. So this is what it contains. It contains a values array, which within the array I can have multiple of these records, and these records contains a data field, which contains the text field, which contains the actual text that I want to extract some information from. In this case, I want to extract the opinions from this text and see what sort of connotation those opinions have. So I'm sending this to my functions. The functions app, what it's doing is accepting that as a request, and then it's, as you can see here, is going from the results values. So results values is pointing to this values array. And basically, I'm just iterating through this array. So I'm going, okay, give me all the JSON structures within this array. And the way I'm doing that is here. So for value in values, so I'm iterating through that. And I'm just getting every record, JSON record in that array, storing that in this output, in this, this results values array. And then I'm taking that and calling the transform function here. Yeah, transform value. And the transform value function, again, this is pure Python code here. There's nothing out of the ordinary. The transform function is actually authenticating against my opinion mining text analytics service, and is sending that data. So it's getting actually the text data and sending that into the text analytics service. So here, for example, I'm saying, give me the textual information from that record. So data text, which you saw here was this bit, so data text. So I'm sending that against text analytics. Oops. And text analytics then is calling, I'm calling this method, where I basically define that. So then I'm just going through the document, which is basically the response that gets returned from text analytics. I'm traversing through that to get the aspect, the sentiment, and the opinion of that piece of text. And then once this function is executed successfully, the return value, it will be a JSON response, which contains from that piece of text here, the food and service were unacceptable, but the concierge, let's do this first, but the concierge were nice, right? So let's show you this example first. Right, so aspect here is food. Sentiment is negative because of the word unacceptable, and the word unacceptable isn't the opinion itself. Again, service, as you can see, food and service are both part of the same sentence that were unacceptable. So it's also with a negative sentiment because of the word unacceptable. However, concierge has a positive connotation because of the word nice. As you can see here, concierge is nice. So you can see, you can do really interesting analysis based on the structure. And the beauty of this is that you can handle negation. So you can say, for example, we're not nice, and send that again. You can see now the concierge is negative, even though the word is their opinion nice, because of this negation, not nice. So you can handle negation as well. So it's quite powerful in that sense. And then this I can use from Azure Search to apply that against all my index data, right? So I can just call this opinion mining trigger websites functions, which calls my text analytics instead, and return all the JSON response, which I can then embed within Azure Search to enrich my my search capability on top of aspects and opinions. And for example, I can say, okay, give me the aspect opinion from Azure Search, and give me, aspect opinion food, and give me all the connotations with food. What are the opinions for that aspect? I can say, for example, for food, there's opinions like unacceptable, bad, good, excellent, really delicious. I can get all those types of opinions for the aspect food, and same thing for aspect service. So I can do that kind of search by interacting with text analytics and Azure Search, combining those two together. So you can see how powerful that can become. Okay, so yeah, so that's pretty much it, what I had to share with you today. Knowledge mining is really a hot topic right now, and we're seeing loads of our customers getting interested in knowledge mining because there's so much unstructured data sets out there coming from social media, from audio files, from all types of historical unstructured data sets that have been stored historically within organizations and have been digitized, of course, from all types of documents that come in paper format. And people want to gain insights from those. So knowledge mining with Azure Search, and as you saw now with text analytics as well, can really enable you to gain some really valuable insights from all that data. So on that note, I will end my presentation now, and I'm happy to take any questions that the team here has gathered from the chat or anything that comes now.
So we don't have any questions yet, Fatos. So
Okay.
we'll just wait, see if anyone has anything they want to ask.
Sure.
Okay, so nothing's come in. So must have answered all the questions in the chat. So just want to say thank you for that great presentation. And there was still 2 more events in this series, same time next week and the week after. And I'll just pass back to Emma to see if Emma, you have any final comments.
Yeah, thanks, Robin. I am just going to drop in a couple of links now to the chat. So these are just for any follow-up learning that you might want to do, and we can make some suggestions through following these links to Microsoft Learn. As well as that, we do have a survey for all of our sessions. So again, I'll drop a link into the chat for that. We really appreciate any feedback we can get from these sessions, and it's really valued. So any feedback you have would be fantastic. So just copy in now. And I see a couple of questions now coming through. So let's see. Someone has asked if it's possible to rewatch this. So yes, all of these sessions are being recorded and they're available to watch on demand. I posted a link in the beginning to the series page where all of those on-demand videos will go. So that's where you'll find it.
And then just questions on technology. So can this service scan your emails so that text can be analyzed?
Can you repeat that, Robin?
Yes. Can this service scan your email so that the text can be analyzed?
Can the service get what was that? What was the actual word?
Scan your emails?
Oh, scan. Sorry, I couldn't get that one. Yeah, of course. I mean, as I said, so any type of unstructured data set can be ingested into like a landing zone, like a storage account within blob storage, for instance, and then it can be indexed by Azure Search. And I'm actually doing that right now for a customer. So they have a bunch of emails coming from their O365 account, where that's landing raw in its raw format in a blob storage account, and we're indexing that using Azure Search. And of course, you can connect. There are connectors to, let's say, if you're using Outlook, O365 connectors that can be leveraged to connect to your O365 account and get that data over into an Azure storage account and then index that using Azure Search. Or if you're using another web server, like an email service, we can of course leverage existing connectors that exist either from the open source community or inbuilt from that service to extract that data first, land it into a storage account, and then index it using Azure Search. So it's entirely possible. Yeah.
Okay, good. And we got another question. It's quite a long one. Is it possible? Let's assume I have a website where everyone can give their innovative idea or content. I will try to find that innovative idea or content is new or copied from another website. If it is copied from another source, I need to check those content or ideas and how much percentage match they were already, and list the top 15 to 20 websites or sources.
Okay, so that's an interesting one, almost like a startup idea. Yes, it's entirely possible to do it. So you would need to first extract the text from the website, and actually the key technology that you would use here would be something called text similarity matching. So you would get text from your website, so all the innovative ideas, and then you will source out ideas or businesses that that exist out there, and try to do some sort of similarity matching between what you have on your website and what exists out there to see how similar those two ideas are. And you would do that based solely on the text information that you have from both sources, your innovative idea on your website and other websites that exist out there. And then you can do that similarity matching. I covered this actually in my last section, topic modeling. There's a technique called cosine similarity that can do that. And then you can enhance that with word embeddings to do that cosine similarity on top of those two pieces of text to understand if they're similar or not with each other. So yeah, it's entirely possible, but you would need to use an open source library like Spacey or anything, and you can also integrate that within Azure Search as well if you wanted to automate that whole process.
Great, thank you. And that's it for questions. So to say thank you to Fatos, and hopefully we'll get to see everyone same time next week. Thank you.
Perfect. Thank you very much, everyone.